Hello guys, good evening. Welcome to this channel T2CS. We'll start with this session, Uncomplicating Time Complexity Analysis. As I said, we'll be discussing this. So before we start this session, before we get into this, let me give you a brief introduction to what we will have in a longer picture, in the longer run, what we will do. Okay, what we have planned is, first of all, I'll give major focus on this DSA, data structure and algorithm, because as you know, this is very important. Okay, this is very important though for the people who are preparing for this campus rise. Also, uh, like um, uh, some people who are in industry, they also require this sometimes. The people who want to enhance their skills, they will also learn this. Right. Okay. So this is data structure and algorithm. I'll try to cover up all the topics, but let's see how it goes, how how if time allows and all. We'll see that how it goes. Later on, we also plan to go with the DBMS concepts. Okay, like SQL and other concepts of DBMS which we learn. Okay, fine. And also then what we'll do is also cover some programming concept like if some people have some issue with this understanding functions, we'll also do that, right? And like recursion and all, like several topics are there, several concepts are there in programming. We'll also cover that, right? And some programming languages like Java. When I say Java, we'll cover OOPS, right? We'll focus on OOPS there because OOPS is also important when you go for an interview. OOPS is also an important topic to cover. And yes, Python. How can we leave Python? Python is like trending language, so we will also cover up those things. We'll see how it goes, and I'll also try to touch some topics here and there, like some topics of operating system or maybe computer networking. Majorly, this live sessions, whatever I planned, this would largely help for the people who are searching for this job and preparing for campus placements. Okay, so with this, let's start our session, uncomplicating time complexity analysis. I'll try to make you understand in a simpler term this topic. I have seen many people have faced problem, but anyway, this is very simple actually. Maybe we haven't looked this in a proper way, so let's do that now. Okay, right? Let's yeah, I see some queries here. Any machine learning on the list? The thing is, we'll try. I planned it to keep it, but not sooner. Later we can have. Okay, surely it is in the plan, it is in the list, but we will do it later, not now. First, I want to have this focus on this thing, data structure algorithm majorly, and some things around the topics which would help these people for campus related thing. Okay, later we can go for the other things which will upskill those who are in the industry itself. Okay, fine. So let's start this session. I'll show you the contents, like the topics which we would cover in this session. So these are the topics as you can see here. We'll first have a quick introduction, okay, and we'll see what is this time and space complexity. There are two things which we need to understand: time and space complexity. Then we have this asymptotic notation. Pardon me, there is a spelling mistake there. Asymptotic notation. Okay, then we'll have this. We'll see some various kinds of time complexity here, and then finally we'll find time complexity, or we'll basically analyze some piece of code snippet. What would be the time complexity of this code? Kind of this question we will do. Okay, so without wasting much time, let's start with the session. Okay, fine. Okay, so let's start the session, guys. I hope you would enjoy, and don't forget to like and subscribe. Okay, fine. So the first thing I want to discuss is this time complexity. What exactly is this? What is then space complexity? So this is very simple. First of all, let's see what algorithm is. What is an algorithm? Algorithm is nothing but some set of steps through which we do a process or we do a task. Given a task, there are various types of like ways in which we can do the task. Let's say take an example of making a tea. We have to prepare a tea. So there are, let's say, three or four people, and they all have been given the task of preparing the tea. So there are various ways in which one can prepare a tea. Like some people first boil the milk and add the tea, or some people they would first boil the tea in water, then they will add milk. Okay, so there are various ways. So what do you mean by this? When we have various ways to do a particular task? So there are, let's say I am saying there is a task T. Okay, I hope it's visible to you. T1, let's say there is a task, or I'll just say T, not T1, we'll just call it as T, let's say. So there is a task T. To do this task T, we have various algorithms. Let's say A1, A2, A3, and A4. Four algorithms are there. So we always go for the best algorithm. So if there is multiple ways to do a particular task, we'll always go for the best way, right? So how would we choose the best algorithm? How would we choose here? Which one is the best algorithm? So there are two things which on based on which we choose. One is time complexity, one is space complexity, right? Like this, I'll give this example. Like I said, tea preparation. Okay, let's go get into this cooking thing. If you are cooking something, okay, some people they use many utensils to do and the same cooking, like for the preparing same dish, some other person may need or may use very less number of utensils. So here it comes space complexity. Okay, so if you want to reduce the space complexity, then you will prefer a particular algorithm which would use less space or less utensils, as the example I have given. And let's say one more person, and there is a person, and the same person, let's say the same person is the person is using many utensils, okay, many utensils, but taking very less time to prepare the food. Okay, then if you want to select the best algorithm, depends on your need, what you want. You want the process to be faster, or you want it should take less space. Okay, that is, like, let's say you are very lazy, you cannot wash all the utensils after food is prepared, so obviously you'll go for less utensils, let it take some more time, like many bachelors do this thing, right? So uh, that depends on your requirement, what you want to do. But normally, see this, if I talk about this computer science, what happens nowadays, space is very cheap. Space is very cheap. Like now we get this 1 TB, 2 TB hard disk. If you buy, it is very like it would come 2 TB hard disk. It comes with maybe 5,000 or 6,000, within 6,000, right? So space has become very cheap nowadays. But time, no one has time. Everyone wants that the task should be finished in very less time, so that he or she would get some extra time for relaxation, maybe Netflix time, Netflix and chill. Okay, so that depends. So that is why nowadays the major focus is on time. Okay, we prefer an algorithm which would take less time to do the task. Okay, space is available there, cheap. Now it's very cheap, so we can have space, no issue on that. But time. So that is why we pick an algorithm based on time. Let's say here algorithm A2 will take less time. So we will say A2 is best algorithm among this. We will go with this because it takes less time complexity. Okay, so that is what your time complexity, a comparison between your time complexity and space complexity. You have to compromise between this time and space. Okay, then let's talk about what are the various time complexity. Okay, we'll come to that later. But let's say what is basically this time complexity. We'll see. So basically, we give an order here. We don't exactly put the time that okay, this task takes 1 hour or 4 seconds or 5 minutes or 15 minutes. No, we don't do that. Actually, we give an order of the time. Why order? Because whenever we are analyzing two algorithms, we cannot analyze two algorithms based on very less number of input. Because when you have very less number of input, the algorithms may behave differently. So always we will assume that there are like a very large set of input. Based on that, we will try to find out the time complexity of the algorithms and we'll compare them. Okay, do not compare two algorithms when when you are assuming that there are very less number of input. No, it would behave differently. It would have a different behavior when input increases. When I say number of input, see number of input, I'll take it as n. So you'll ask what is n? Okay, sometimes there is a confusion also there, like what is n is number of input. Okay, but let me clear this. See, if you are talking about an array, n there would denote number of elements in the array. There it is number of input. But let's say you are trying to find out n factorial. There n is a number. So how large is that number? That would like the time complexity would depend on that. Okay. So this is the thing here. Okay, right, got it. So this is how it depends on the number of input. So as you increase the number of input, your time complexity will obviously increase, right? Okay. So let's see this. Let's see this. So one thing is very clear here. We would compare two algorithm on basis of large number of input. We'll assume that there are very large number of input, and based on that, we'll compare with the time complexity. Got it? Okay. So here there are various asymptotic notations. What are asymptotic notation? Like these are some notation which are used to denote the time complexity. As I already said, we do not give the exact time, but we represent the order of the time, right? We give the order of the time. Like what order? Order of your number of input. Okay, we represent always we represent on the basis of the number of input. Okay, so as I say, there are various asymptotic notations. What are they? Okay, can I get some response in the comment box? What are the different asymptotic notation? Like how many? Let's say how many asymptotic notations are there? Can anyone? I'll just wait for a while for you people. Can anyone put up here how many asymptotic notations are there? And also, if you want to put, you can also put what are they? Okay, you can also name the asymptotic notations there. Okay, Satyajit says three. Got it. Anything else? Like anyone wants to add anything to here? I'll just wait for a while before I move on to my explanation. Yeah. Okay, Satya says big omega. Okay, this is one of Sabya Sachi. Okay, says four. Fine. Okay, fine. Theta and big O. Okay, let me clarify one thing. There are actually more than three. Okay, there are more than three. Actually, there are more than three, but we use this three. We use this three for our purpose. The rest of the things, you might know this big O, big omega, and theta. That is actually big theta. We also have big small omega, small o, also small theta. They are used for research purposes. Okay, we don't use them. So we are concerned about these three things. We use these three: big omega, big O, and your theta. We normally call it theta. So what are they? Let's have a discussion on this. I'll just clear it out. So I'll draw a graph and try to explain based on that. Fine. Just give me a moment. I hope it's visible. I'm drawing something. Is it visible to you guys? Please comment down. Is it visible? I'm drawing something here. I've drawn something here. Is it visible? Can I get some response in the comment box? Okay. This is, yeah, thanks for the confirmation. So this is your n, number of input or the size of the input, and this is your time complexity, you say. And let's say I'll denote your task, your process or your program is running, or I can say I'll denote it as f of n. F of n is the like the function of your program or process. So let's say this behaves in this way. Okay, your graph f of n goes in this way. Let's say, okay, right? This is the behavior. So this is how f of n increases with n. So t of n, y-axis here is time complexity, and n is your number of input. Fine. This is the behavior of f of n. So we talked about three things: big O, big O. I hope it's like kind of clear. Whatever I'm writing, please let me know if it is not. So, okay, we have this big O. Then we have, normally we don't write big O. We just write the denotation is this. So we denote it as this big O, and inside it some like the representation of n. And then we have this big omega. Then we have this theta. Basically, the big theta. So this is f of n. Fine. So big O is used to denote worst case time complexity. Worst case time complexity. How is that? Let's say I'll take another curve here which would behave in this way and it will increase like this. Let's say, and I'll call it as g of n, for example. is g of n, or I'll call it as, yeah, g of n. Let it be g of n. Okay, so as you can see here in the curve, when okay, let me mark this point. I'll call this as n naught. Okay, so if you see before this point n naught, see the graph is behaving differently. F of n, maybe sometimes it is less than this g of n, sometimes it is more than g of n. That is why I said will not assume there are very less number of input. Will assume and will analyze an algorithm by assuming large set of input. Okay, so after this point n naught, after a certain point n naught, this g of n is always greater than f of n. So this denote this g of n graph. Okay, this, basically we should say this as C1GN. This denotes your big O. Okay, and there may be some other graph, kind of, let's say uh, this. Okay, maybe this. We'll call it as C2GN. This denotes your big omega, best case. Big O is worst case. That is why it is greater than f of n, and omega is best case. That is why it is less than f of n. Okay, this is the other thing. So big O is used for worst case time complexity. Big omega is used for best case time complexity. And when we are comparing two algorithms, we will always go for worst case time complexity. That is big O. So we are will our discussion will majorly focus on this big O thing. Okay, we will not take care about this big omega, and one more is theta, that is average case. Okay, between this big O and big omega, that would be average case. Got it? So if big O and big omega, let's say your worst case time complexity is big O of n, and your best case time complexity is also big O of n. They are same, right? Then we will go for average time complexity. We'll find out the average time complexity. Okay, when both are same, when worst case and best case are same, well, we will go for the best, sorry, average case time complexity. Anyway, we are not worried about that thing. We would focus our discussion on worst case, because that is what we are concerned about. We would compare two algorithms based on worst case time complexity. At worst case, what will happen? Okay, fine. If n is very large, worst case, we'll compare two algorithms on the basis of that. Fine. So before I get into this, before I start discussing this basic various things, what are the various types of complexity and all, I hope you now have a basic idea about the various time complexities. Okay, see, I don't want to get into much detail here, because it would be a boring session then. Okay, and also there is a time constant with us, so we have to stick to it, because there is like, and also it may not be required for you. If you are really curious enough, then you can just have a look on it, a search on it. Okay, if anyone needs to know like more details about this asymptotic notations and what are the things, there are several definition and all, you can comment down. Okay, and in upcoming session I'll plan a special session for this. Okay, so like a detailed explanation for this various asymptotic notation and how do we go for it. But for the time being, we'll move on for the next thing. Okay, so we now have, I hope all of you now have a basic idea about time complexity. Okay, so I just want to show you one thing. Okay, if time complexity was explained like it is explained now, right? We have a basic idea now. Does it become less complex? Well, it will it become less complex? No, it is still the same, right? It will not become less complex. We just now understand the complexity. That's all. That is why this session is named as Uncomplicating Time Complexity. It is still complex, but now we have a understanding about it. Okay. Okay. Moreover, if any like if people need more details on this asymptotic notation and all in detail, like I will arrange one more session. You can comment down if you need it. Okay. So let's move on. Let's see the various kinds of complexity. So you can see the topics I have mentioned. We have done the introduction part. Okay. Then we have this discuss what is this time and space complexity. Space complexity basically what? Like you are doing some problem. What is the extra space that would require? Okay. Don't take into account the space the given. Let's say an array is given and it is said to you to reverse the array. For example, reverse the array, and you have followed a technique in which you will use another array and copy the element from the reverse order. Let's say. Let's say you have followed this way. So here, do not take into account the given array. The memory, the what extra space you are taking for this process, that is what you, that would be called as space complexity here. So what is the extra space you are taking for this problem? One extra array, that's a number of element n. So you, the big O of n would be the space complexity there. Got it? Fine. Let's carry on. Okay, and yes, don't forget to subscribe the channel. Fine. So let me clear this out and we'll move on to the next topic. Any doubt till this point? If any doubt you have, you can post in the comment so that I can address that. If you don't say I would not know, so it would be better. If any doubt till this point, you can add in the comment box. Okay, fine. Anyway, guys, so I hope it's clear up to this. Whatever we have discussed, that is clear. Let's now discuss about various time complexities. So we denote this. Okay, sometimes we denote this big O of 1, sometimes we denote big O of c. What is this? What is this? Constant time complexity. Okay, constant time. If a task is done in constant time, then we say this big O of 1 and big O of c. You can use big O of 1, no issue. C is also here is a termed as a constant actually. Okay, here c is a constant. It is assumed to be a constant. So what are the unit time complexity? Like one task. Let's say you are printing something. Okay, so if you write printf in, I'm just writing a C code. Okay, code, not basically a code, proper code, just a snippet. So if I will print this 10, so this will take constant time, unit time. So for this statement, you can say this statement will take big O of 1 time complexity, constant time. So this is constant there. Then it comes big O of n, linear. So it linearly depends on the number of input. Okay, there are various examples. Like you might have heard about linear search. You might already have done this. Linear search is big O of n. Okay, this is linear time complexity. Then we have what is that? Log n. You can go for log n. Logarithmic time complexity. Okay, this is nothing but this binary search. Okay, you might have done binary search algorithm. You have might have applied binary search algorithm on an array to find, to search an item. So there it is log of n. Log n would be time complexity for that case. Then we also have um, let's say this n square on all. This is quadratic time complexity, right? This is quadratic time complexity. This is quadratic time complexity. Cubic and cube and all, fine. This is cubic time complexity. Then we'll have this is also exponential time complexity. Okay, fine. This is also there. Also, what you can do is we can have big O of n factorial. Okay, time complexity would be n factorial. Then we can have n to the power n. This is also there. See, I have not written any. Like, I've not written in any order. I've just mentioned you what are the various time complexities. Okay. So constant time, linear, logarithmic, cubic. Sorry, quadratic, cubic, exponential. This is factorial, n factorial, and this is n to the power n. Right. Okay. So let's. So this is all about your various. Types of complexities. I hope it's clear and visible. Is it like clear to you, everyone? Clear, right? Fine. And till now, no one has any doubt on this point. Okay, fine, great, great. You are following. So if that is the case, I'll just erase these things up and we'll go to some discussions. Okay, so these are the various types of complexities we will deal with. Okay, and one more thing, guys. See, in this session I have just planned for this time complexity, like analyzing the time for iterative version. We will not cover time complexity for recursive logic. That we will do in a different session. Okay, to be very clear. Fine. So we have done this various time complexity we have looked on. There may be some other time complexity. We will see some examples and then we would get to it. Okay, so to start with, I'll just start with a very simple example. Okay, so see this. If you have been given a code, let's say, yeah, okay, fine. You write for I equal to 1, I less than equal to n, I plus plus, right? And let's say there is some statement here, printf, will write here printf hello, for example. Okay, and someone asks you what would be the time complexity for this. We denote normally T of n. T of n is nothing but time complexity. So what would be the time complexity for this code snippet, for this loop? So what exactly here we need to find? Okay, so some people will say we will just find out the number of times the loop will run. I agree. I don't say that is wrong, but I want to change your perspective here. Okay, that will not maybe it may not make any difference here in this particular code, but it will surely make difference when we discuss some other examples. See this. I want to think this as how many times this statement is executed. It may seem very obvious. You'll say obviously this statement would be executed on the basis of how many times the loop will run. Okay, but why I'm saying when the problem statement changes, when some will do some other example, there it may be maybe I'm saying maybe confusing when we will deal with more than one loop. Then it may be confusing actually. So if you focus on the statement rather than the loop, then it will be easier for you. Okay, everything will get into place. What I'm saying basically, it may not be very clear with you right now, but when we solve some problems, some examples, it would be very clear with you. Okay, so I want to focus on this part. I want to see, I'll check how many times this statement would execute. Obviously, this is just a normal loop, one the single loop we have. This loop will run for n times. So this statement is going to be executed n times. So this should be big O of n. Time complexity would be big O of n. N times this loop is running. We don't know the value of n. Okay. So now we have depicted the time complexity for this code on the basis of or in the order of number of input or size of the input. We go of n. Worst case, we are talking about here worst case. Maybe n would be anything. N would be 5, 10. We don't know yet. No. We are assuming that n is something large, very large. Okay. So this is big O of n. Coming to this, if I write here for I equal to 1 and I'll say I less than equal to n by 2 and I'll say I plus plus and I will have some statement. Let's say this time hi. Fine. What would be the time complexity for this one? Just post your answer in the comment. Post your answers in the comment. What do you think? What would be the time complexity for this one? Yeah, guys, I would wait for a few time. Just comment down your answers. What would be the time complexity for this code? We have done the first one. What would be the time complexity for this code? Okay. Someone says n. Anybody else want to change the answer? Satyajit Panda says 1 by 2. Fine. Okay, I hope it would be either n or n by 2, right? Nothing else. Because as it is very clear, the loop is running for n by 2 times. So it is very clear here as it is running for n by 2 times. So either it would be n by 2 or n. So we need to discuss or we need to finalize what would be. It would be n or it would be n by 2. No, it surely would not be log n because see, it is I is starting from 1 and it is incrementing linearly till it reaches n by 2. Let's say n is 10. So I would start from 1, then 2, then 3, then 4, then 5 and it would stop there. It will not continue. The loop will not continue after this point. Okay. So 5 times, that is n is 10 and the loop is running for 5 times, or you can say rather the statement would be executed 5 times, which is n by 2. Got it? So we can say it is n by 2. I'm not saying it is wrong, but to be perfect, it should be n. We should write this big of n by 2 as n. Why? Remember this. We are not dealing with the exact time. We are just representing or denoting the order of the time. So any constant in the expression, you would just ignore them. Let's say it is n by 2, ignore 2, just say n. If it is 5n, just write n. If it is, let's say, anything n by 5, you will just say n. So you'll just ignore the constant terms here. If you have 3n by 7, even then you will say n. Even then you will say n. Got it? Okay. So we'll just ignore the constant terms in this time complexity notations or the order of the time complexity. We'll just deal with the n thing. Also, one more thing I would like to discuss here. Let me clear this part and I'll discuss few things here. Let's say your code depends on n as expressed in this way. I'm writing a thing here. Just a moment. Let's say it is 3n square plus 5n plus 7. This is how your program is depending on the n number of input. This is the expression, let's say. Would we say that time complexity would be big O of 3n square plus 5n plus 7? Question. So this is just a question to you. Answer me. Would we say time complexity for this would be big O of 3n square plus 5n minus 7? Yes or no? Just say yes or no. Yeah, I'll wait for a while. I'll wait for a while. Just say yes or no. If your program it depends on n, the time complexity may be would be of this order, which is denoted by this function. Would we say time complexity would be this? Okay, Satyaj says no. I see some people saying no. Anybody here says yes to this? Is it? It would be. Would it be yes? Can we so write this again? See, as I said, we will not deal with the constant terms. So, if we will not deal with constant terms, then should we say n square plus n? Is this the time complexity? Say, yeah, guys, you can comment, comment your answers. Is this the time complexity big O of n square plus n? Yes or no? Again, yes or no question. Big O of n square plus n. Yes, okay, Satyaj says yes, it is big O of n square plus n. I expect some more answers here. Yeah, guys, answer. Answer, guys. Fine. Okay, see, we will still not say that this is the time complexity. We will say big O of n square is the time complexity, not n square plus n. Why? We are dealing with worst case time complexity, guys. Okay, please remember this. We are dealing with worst case time complexity. So given if you get this kind of terms, always go with the term with highest degree. Okay, ignore this. So n square. N square would be the time complexity because we are not aware of what exactly n is. N may be very large. So obviously when it's very large, n square is like too large. So it would also contain this. So we'll not write n square plus n. So ignore those terms. Just go with the term with highest degree. That would be your worst case time complexity. So we can denote this as big O of n square. Okay, this is one more point. That is why, so we got our solution here for this code, for the given code, second code, it would be big O of n. The time complexity would be big O of n. Right. I hope it's clear. Just put thumbs up, guys. If it is clear, just put thumbs up. I'll just wait for a while so that I'll be like on like I'll get a confirmation that you got this. Yeah, just put a thumbs up so that I would get to know. Like it's clear, all clear, and no doubt here. Clear, fine, great, great. So we'll move to the next thing. We'll move to a different example here. Okay, so yeah, thanks for your responses. So I have this for I equal to 1 and I'll say I less than equal to n, and I'll say I is equal to, or let me write in a different manner. I'll just write I into equal to 2. Right. So this is nothing but your I is equal to I into 2, right? If this is the case and I have the same printf, I'm just writing pf for printf in short. I'll just write here key to cs, let's say. Pardon my handwriting, I am not very good at this handwriting. Okay. So what would be the thing, what would be the time complexity for this one? What do you think so? What do you think about it? What would be the time complexity for this code? I starts from 1, I would go till n, and every time I is getting incremented by 2. So what do you think? What would be the time complexity for this? Okay, so I'll just wait for a few times so that I would allow you people to answer. So you can put your answer in the comment box, and we'll discuss. Anyway, we'll discuss this. Well, we'll just allow some people to answer this question. Okay, I got some like I got one comment with saying n fine is okay. Any more answers, guys? Yeah, quick. Just think about it a while and put your answer. N plus 2 equal to n. Okay, fine. So it's still n here. Anybody else wants to change the answer? Yep, please put comment. Comment your answer, and we will discuss. We'll have a discussion on it. Okay. No more answers. Shall we go? Okay, great. So we will continue this session. Certainly, it would not be n. Okay, it would not be n. Rather, it would be log n. Okay, the answer would be log n here. How? Let's see this. Take any value of n. Let's say n value I have taken 64. I should not take. I have said already that we should not assume n as 64 here. Okay, like it should be very large. We should not take 64. But to understand how it works, we will take a value. Let's say n is 64, and I value starts from 1. In the next iteration, I value would be 1 into 2, that is 2. In the next iteration, I value would be 2 into 2, that is 4. Next iteration, 4 into 2. Okay, right. Next iteration, 8 into 2, 16. Next iteration, 32. Next iteration, I into 2 would be 64. Got it? In the next iteration, like this is like you can say up to this a loop will run. Next time the loop condition would be false because it would become 128, which so this condition would be false then. I less than equal to n. This condition will be false, so the loop will not run. So up to 64, this loop will run. So basically, you can say, can you say how many times the loop executed, how many times, or how many times this statement executed? Okay, how many times? In how many steps? I reached 64 from 1. I started from 1 and it reached 64. Got it? In how many steps it did reach 64? If you see it clearly, we have reached in 6 steps. Okay, in 6 steps we reached from 1 to 64. That means the loop has executed for 6 times, and that means the statement printf t2cs has been executed for 6 times. That is our time complexity, right? The number of times the statement has executed is the time complexity here. That is 6 here. But here we are not worried, like we are not concerned about the number here. We have just assumed 64. We have to denote this in terms of n, right? So just find out a relation between n and this number of times the loop is executed. I'll say, let's say this is k, number of steps, or you can say number of times the loop has executed, or the number of times the statement has executed, that is k, and this 64 is, let's say, n, because we have taken value of n. So can you find the relationship between k and n here? 6 and 64. You can say 2 to the power 6 is 64, and so you can say 6 is nothing but log of 64 base 2. Log of 64 base 2. So here we got a relationship, that is k is equal to log n base 2. One more thing, guys, here in computer science you don't have to write base as 2. If you write just log n, that like by default it is 2, base is 2. You don't have to write log n base 2. In mathematics, if you don't write anything, if by default the base would be 10, but here in computer science by default the base would be treated as 2 if you don't write anything. Okay, because it works in binary, right? base 2. So k, the relationship between k and n is k is equal to log of n. K is what? Number of times the statement has executed. That is nothing but the time complexity. So T of n is nothing but, so for this particular code, T of n is nothing but big O of log n. You don't have to write base 2. Clear? I hope it's clear. Put thumbs up or just say yes. Anything you can do so that I'll get confirmation that it is clear to you. Clear, right? Yeah, guys, I'll just wait for a while for your response. Yes, clear? Fine. I hope it is clear for everyone. I just got one response. I hope it's clear for everyone. Okay. See, so I'll just clear this stuff and I'll discuss one more problems. See, only knowing the theory behind it will not like help you. How to solve the problems, how to find out the time complexity of various examples. That could, if you understand that, then it would be much clearer. That is why I'm taking some example and explaining you here. Okay, see. So the next example I would take is for I equal to n, I greater than equal to 1 and I divide equal to 2. Okay, I have the same printf statement as key to cs. What would be the time complexity for this one? Say, yeah, say guys. I'll just wait for your response. What would be the time complexity of this code snippet? What do you think? What would be the time complexity? Just think about this a while and answer this. This is easy for you now. After discussing some examples, this should be easier for you. But anyway, if it is not clear, even we'll discuss. No issue. We have kept this session for that purpose only, right? So no issue on that. Just answer what do you think about this question. What would be the time complexity for this question? I'll just wait for a while. Okay. Yeah. Would I get some response? Like, is it understood this question? Can you get it? Can you put some answers? Yeah. What would be the time complexity for this one? What would be the time complexity for this code? T of n would be what? We have already discussed the previous example. We have discussed some one or two examples, right? So what would be the time complexity for this one? It is very like it is related to the previous question actually. So you can answer this. I hope you can answer this. N, okay. I got some response as N. Anything else? Anyone wants to say like some other answer here? Okay, I'll just wait for a few more moments. Please answer this. What would be the answer for this code? Would it be N? Or you want to change this? Okay, I don't get any response. People, I just got one response here. Say it as N. But certainly this would not be n. Okay, it should not, it won't be n, it would be the same log n, because see, if you see the loop, I just started from n and every time I am like going down by 2. You can say we are dividing it by 2. Take the same example, like take the same example. I, let's say I is 64. So I value will start from 64. Every time I'm decreasing it by like dividing by 2. So next time it would be 32. Next time it would be 16. Next time it would be 8. Next time it would be 4. Next time it would be 2. Next time it would be 1. So this is where it will stop. Like next time it would be 0, but we will not count that, because that is where the loop will stop. The time, the number of times the statement would execute would depend on this steps. How many steps? Same, right? 6 steps. And we already know 6 and 64 relationship. It's 6 is nothing but log of 64. So relation here is k is log of n. So time complexity here would still be okay, my bad. Log of n, big O of b, big O of log of n. So one thing here is very clear. If y starts from 1 and every time it is incrementing by 2 times, or if I starts from n and every time if it is getting decremented divided by 2 times, both of this will give us this log of n time complexity. Even if it is increasing by 2 times or even it is decreasing by 2 times, we'll get log of n. Similarly, see, not I'm not saying only about 2 here. Let's say in a question it may be given I is equal to I into 3 or I is equal to I divided by 3. Okay, it may be also given, right? In this scenario, your answer should be log of n base 3. That's all. If it was into 2 and divided by 2, it was log n base 2. If it is into 3 and divided by 3, it is log n base 3. Okay, see, again, you can also still write this as log n. I'm not saying if you write log n it would be wrong. No, you can write 3 is again a constant here, but it would be better if you mention the base here. So log n base 3. So I just want to write a generalized formula here. If it is I equal to I into k, and if it is I equal to I divided by k, this is how it is incrementing or decrementing, or maybe you can say updating the loop variable or counter variable. If it is updating in this manner, we can say the time complexity would be log of n base k. Okay, right? Got it? This would be the time complexity for this kind of code snippet. I hope it's clear. Got it? If you have any doubt, please put up your like doubt. I would address that. If you could not get this, please put up your question or your doubt, whatever, in the comment box. Also, what I'll do is, yeah, in the next session onward, what we will do to have your session, or maybe it won't be very like it won't be possible to cover like address doubts of everyone here in this session. So what we'll do in the next session, from next session onwards, we will roll out a form, Google form. You can put up your question there. Okay, and in the next session I would address to those questions. Okay, maybe see, because I see people sometimes are very concerned about like, or maybe they are very okay, introvert, and they don't want to put up any comments or answer or questions in the public comment. So in that case, I'll roll out a Google form from the next session, so you can put up your questions there. I'll just go through them, and in the upcoming the very next session, I would cover those things first, and then we'll cover the different thing. Okay, fine. So I planned this to be done today, but due to some issue, I could not do that. Anyway, we'll roll out the same in the next session. Okay, fine. So let us go to a different question. This is done. So we got one thing here. Then let's say, uh, what should we do now? See this. One more question. We will do for I equal to 1, I less than equal to n, I plus plus, and let's say then we have for j equal to 1, j less than equal to n, j plus plus, and there within that I have this key to cs, let's say. Okay, so what would be the time complexity for this one? This is easy, right? Everyone can answer. Just comment your answers for this. For this code, what would be the time complexity? If we have here a nested loop, I equal to 1, I less than equal to n, I plus plus. Inside it, we have this j loop, j equal to 1, j less than equal to n, j plus plus, and we are just printing key to cs. Okay, so this one can think in this way. So this is running for n times, this is running for n times, and this will take constant time. I may write it as 1. So you can say it would be like n into 1. So you can say that it would be n square. You can think of it as big of n square. Yeah, fine. It is also correct. You can go in this manner. And it is running for n times. The inner loop is running for n times, and this will take constant time. So together it would be n into 1, n square. But remember what I said, I don't want you to go in like as per this way. I want to change your perspective. What I want is just look at this thing. Okay, focus on the statement, how many times this statement would execute, that you see. Okay, how it would change your understanding. See, I'll explain. This is I. Okay, let me choose a different color. That would be better if I choose a different color. Fine. So this is I. and this is, let's say, j, I and j. I starts from 1. When I is 1, j will run n times, right? For j equal to 1, right? J will run for n times, 3, 4, so on up to n. Fine. Okay, total how many times loop executed? N times. Then when I is 2, j would still run from 1 to n. Total how many times loop executed? N times. Similarly, when I value would be n, j loop will run for n times. So how many times in this iteration the loop executed? N times. So if you add this all together, it is nothing but n plus so on up to n. How many times you are adding n? Total n times, because I value, for each value of I, we are the j value would be 1 to n, so loop is running for n times, or you can say for each value of I, this statement is executed for n times. How many values of I are there? N values. So that means this loop would be executed n times. In each iteration, statement would be executed n times, and there are how many iterations? N iterations. So you can add all these times. Total you'll get, oh, so this n times, you get total you'll get n into n, that is n square. You can go in this manner. But I want you to perceive this, or see this code, or this analysis of time of this code in this way, not the previous one. No issue. That will also give you the correct answer. If you see outer loop is running for n times, inner loop is running for n times, and the statement is constant time, so it would be n into 1. How, why would we multiply here? Obviously, because if for each time for I value 1, j is running for n times. For I value 2, j is running for n times. For I value 3, j is running for n times. Similarly, when I value would be n, they will run for n times. Okay, so how many n times are there? N number of n times. So we are just adding them together, or multiply. You can just multiply n with n. So you'll get n square. So time complexity for this would be n square. It is quite easy. I just picked this question so that I can explain you this perspective, this way of seeing to this question. Right. Okay. So this would be n square. This should be n square. So see this. Fine. I hope you understood the way in which I am proceeding, so that it would be easier when I change some portion of this code. Like, let's see one more example, and I hope you would understand after we discuss this perspective, like this way of doing it. I hope that you will understand. Okay, is there any doubt on this particular question, like how we got n square? Both the ways, we have seen two ways. One is this way of solving, then we looked on into a different way of analyzing the time. Okay, you just understand why I am telling you to follow this way and not that way. Clear? Okay, I hope it's clear. Please put up comments. Is it clear or not? Just put thumbs up if it is clear, and you can just mention no or something if it is not clear, and I would address you accordingly. Is it clear? I'll just wait for a while for the responses, guys. I hope it's clear. Yeah, I have to look here, like for your responses, I have to check there and also come back to here. So pardon me that. Okay, I got yeah, answers. Yes, it is understood. Fine. So then we can go or move on to a different question. So I'll just let me just clear out the things, and I will do some more problems. Okay, this time what I want to do is, let's say for I equal to 1, I less than equal to n, and I is equal to I into 2, and this is for j equal to 1, j less than equal to n, j plus plus, and the thing is still print key to cs. Let's say. Fine. What would be the time complexity for this one? I hope it's visible clearly. Okay. My handwriting is not so good. Please pardon me. I just hope that it is like at least understandable and it is clear to you. If it's not clear, please comment down so that I would rewrite the things. Anyway, if you could see this and if it is clear, just let me know what would be the time complexity for this particular code. What do you think about it? Tell me. Post down your answers. Post down your answers. Yeah, guys, answers. Put your answers here. N square. Okay, I got one answer as n square. We'll see whether that is correct or not. So I got one answer as n square. What about others? What you're saying? What would it be? What it would be? Yeah, I'm just waiting. I'll just wait for a few more moment and then I'll start discussion of this question. Okay. Yeah. Any more answers, guys? Okay, I got one more n. Satyajit says n the log of n square. Okay, we'll check it. Fine. Okay, let's discuss this. Okay, certainly, yeah. Let's find out what would be the. I'll not say the answer right now. Let's find it out and see now how the way that way would help you now. You will say you may think that okay, this is running for how many times? Log n times, right? This we know I equal to I into 2, and sometimes you say okay, this is running for n times. J is running for n times and you say this is constant, no issue. So you just multiply, you'll get n log n. Actually this is the time complexity, but yet I don't want you to follow this procedure, we'll follow that procedure. Okay, because later I'll modify something in the question, so the way of analyzing the code would be different. So just take I value, just take j value. When I is 1, how many times j executed? N times, obviously. So this statement executed for how many times? N times. Then when I value is 2, how many times j executed? N times, obviously. This key to CS was executed for n times. Fine. Then when I value is, next time I value would be 4, not 3, because I is equal to I into 2. That is the updation. J is still running for n times. So key to CS would be printed n times. Fine. Likewise, when we reach n, when we reach n, j would still run for n times, right? So the key to CS would be printed n times. How many times? So how many times we should add n? How many times? Can anyone say how many times? Yeah, push answer. How many times? We reached from 1 to n. So number of iteration of the outer loop, that will decide, right? This number of n's we are adding up. So what would be the number of times here? No, not n square. See, I started from 1 and we reached till n. In how many steps? Log n. We have already discussed. Log n. So there are totally log n number of n which we have to add here. Okay. So in total it is n into log n into n or n into log n, whatever you can write. So the time complexity here comes out to be big O of n log n. Is this clear? See, I value started from 1. Every time it is getting incremented by 2. I 2, then 4, then 8, so on. Then it will reach n. How many steps? In how many steps I reach to n from 1? Log n times. Okay, log n times. So it would be n into log n. There are log n number of n's which we need to add. So it would be n log n. N log n would be the answer for this question. Clear? Is it clear? Clear, right? Okay. So just post your comments if it is clear or not, or else if it is not clear, I'll explain it once more. Yeah, I'll just wait for a while. Is it clear, guys? Okay. See, when you understand things, this would be the power for you. So when you reduce the time complexity of an algorithm from big of n to big of 1, so it feels like you are powerful. Okay, so see, why I'm showing you this is in competitive world, what we are asked is, given a problem, they ask us to solve it in certain time complexity. We may have a solution which would solve the problem with big of n square. Like I said, given a task, there can be many algorithms, many ways, but we have to select the best one. Which is best one? I said comparison based on time complexity, the one which will take less time. Okay, so if you can convert an algorithm which is taking some more time into less time, then you will say, you will feel empowered, right? Now then you'll say, okay, I now rightly or correctly understand this time complexity thing. Okay, that is all about this time data structure and algorithm and your competitive programming. Okay, okay, fine. So I hope this clear. Let's move on to the next question. Fine. Let's see this one. For I equal to 1, I less than equal to n, I equal to I into 2. Okay, we'll not get into this thing. I'll just write I plus plus. And then inside it, I have this J loop for J equal to I, okay, J less than equal to N and J plus plus. And then printf the same thing, key to CS. Right? So what would be the time complexity for this one? What's your answers? What do you think about this? What would be the time complexity? Please be very clear. This is I equal to 1, I less than equal to n, I plus plus, and it is j equal to I, j less than equal to n, j plus plus. Screen not visible. Okay, I'll just do it. I hope now it's clear. Yeah, now it's clear, right? Now it's visible. Okay, just give me a response. Is it visible now? Yes? No? I hope it's visible now. Just answer this. What would be the time complexity for this one? What do you think about this code? What would be the time complexity for this one? I equal to 1, I less than equal to n, I plus plus, j equal to I, j less than equal to n, j plus plus. So now, if you go with that way of doing, like you say this is n times, this is n times, this is constant time, one may think about this and you will say it would be n square. One may think this, but this is wrong. This is not n square. Maybe it may be n square, but this is not the way through which you analyze this code. Okay, we'll see whether it is n square or something different, but certainly will not follow this way of analyzing the code. Let's see. We'll use the same way which I explained. So I will start from 1. I value, initially I value is 1. J will start from I value is 1, so J would also start with 1. How many times this statement would be executed? N times. Okay, so it is running for n times because j will start from this 1 2 3 4 up to n. So the key to cs would be printed n times. Next, what would be I value? I value would be 2. J value would start from 2, not 1, because j is starting from I. So 2 3 4 so on up to n. How many times now? How many times key to cs would be printed? Is it n times? Yeah, same. What would be the number of times key to cs would be printed in this iteration, in the current iteration, would be what? Just post your answers. What would be the number of times the key to cs would be printed in this iteration when I is 2? Yeah, say n minus 1, right? Yes, it would run for n minus 1 because we are now running from, like, j is running from 2 to n and not 1 to n. So it will run from n minus 1 times. Then when I value is 3, j value would start from obviously 3 to n. So how many times the key to cs would be printed? Obviously n minus 2. So on, when I value would reach n, j value would start from n and go to n. Obviously, how many times it would execute? Only one time, right? When I value would be n, j would start from n and it will go up to n. So the key to cs would be printed only once. So if you add all these values, this would give you the total number of times key to cs is printed, and that is nothing but the time complexity. Because I said time complexity is nothing but the total number of times the statement would be executed, which is there inside the loop. Okay, so just add them up. It is n plus n minus 1 plus n minus 2 plus n minus 3 plus so on up to 1. What is this? N plus n minus 1 plus n minus 2 plus n minus 3 up to 1. What is this, guys? This is nothing but addition of n natural numbers, right? And I think you know it. Addition of n natural number would be n into n plus 1 by 2, which will come n square plus n by 2. But as we are writing the time complexity, you can just go with the term which has highest degree, that is n square. So it is still n square, but we have followed a different way. Yeah, perspective is different. Answer is same n square, but will not use this way of doing it. Okay, it may, you may end up with some error if the question is modified a bit. Then you may end up with some error, some wrong answer. Okay, fine. Clear? Is this clear, guys? How we solve this question? See, time complexity, when you're talking about time complexity, it is basically, I would say it is less of your programming knowledge, like the basic programming knowledge, no, basic programming knowledge you should know, like loop and all this. But majorly, you should be well with this mathematics. Okay, mathematics. I've seen people like are scared of mathematics, but that is not the way. Like if you are really into competitive programming and world, then you should not be like avoiding this mathematics. Mathematics is everywhere. Even nowadays, this machine learning and your data science, maths is used heavily there, right? So we cannot run from mathematics. I have seen many memes out there. It has been said, where is maths used? We studied this and that. Where are we are using it? But maths is used a lot in like almost all the field right now. Okay, fine. So this would be n square, and this is how we got this. Okay, I'll just change the question a bit. For that, what I'll do is I'll just clear the things I have written here. Just give me a moment. I'll just clear this out. I don't want to write the code once again because I just want to modify a small portion here. So I'll just erase these things, whatever I have written here, so that the question would be intact there and we can discuss on the modified version. Okay, fine. So I hope it's like clear to you. Like it is visible, clearly visible. Okay, just a moment. Fine. So I'll modify a few things here, and this one. Okay, I'll modify this part, and let's write I into equal to 2. Now give me the time complexity for this one. What would be the time complexity for this one, guys? Can anyone answer? I'll just wait for a while. Okay. Yep. Put down your answers here. Comment here, guys. Quick, guys. Quick. Just think about it a bit and write down your answers here. Post here. Yeah. I'll just wait for a moment. I hope you can do this. It's not very difficult. If you follow the procedure in which we have solved, like just now we have just discussed the procedure, 2 or 3 questions we have done. If you follow the same procedure, you can surely get the answer easily without making any mistake. Just go as per the same procedure. Okay. So I'll just start it, but meanwhile you can put up your answers. So I value here would start from, okay, I'll just do it a bit upside. Yeah, I is, let's say, 1. How many times is j would run when I is 1? When I is 1, j would start from 1, so it would run for n times. Finally, this key to CS would be printed n times. Next time, what would be I value? I value would be 2. So j value would run for, yeah, j would start from 2. Okay, so 2 to n it would run. How many times it is running? N minus 1. Okay, then what about like next, what would be the value of I? Next time value of I would be 4, not 3, because I is incremented twice. So I would be I equal to I into 2. Okay, so j would start from 4 now, 4 n. So how many times the loop is running? here? Tell me. Yeah, tell me, guys. How many times this loop is running? N minus 1, 2, 3 is not there, for 4 it is starting. So kind of this way. Okay. So this is not see how it is different. If you think as okay, this is log n and this is n, you may get the answer, but it may be different when you analyze this way. You might get some different answer. See this. Next, when I would reach n, it will start from n and it will go to n. Okay, so it is one time. So basically, what is this? N plus n minus 1 plus n minus 3. The next time it may not be n minus what is that, n minus 4. It may not be n minus 4. It may be, what would be the value of I? The value of I would be 8, right? Value of I would be 8 here. So you would start from 8. How many values you left out? 7 values. Next value would be n minus 7. So maybe it is n log n. Okay, I'll give you one more example. I just given this example to analyze in this way. See how things are different. When you was following this procedure, things are very different. Pretty much different when you are just assuming the in this way. So we'll not use that way. We'll follow this procedure, guys. Okay. Whenever you get this nested loop, go for this way of solving. Take I, this j, just check out how j is running, how many times for each value of I, how j is running, how many times j is executing, how many times the statement is executing there. So this way you go for. Okay, fine. So what I'll do now is let us see some question. I just given this example to make you understand how things are different when you change your perspective. Okay, so see this one more question. For let's say, what should we do here? Okay, for I equal to 1, I less than equal to n, I plus plus. Okay, then here I have for j equal to I and j. What should we do here? Let's take some good examples. Okay, what should we take? I less than equal to n, I plus plus. Okay, we'll do this one. Yes. J um, less than equal to n and j multiply equal to 2. Let's say enter E2CS. So what do you think? What would be the time complexity for this one? What would be the time complexity for this one? Answer this. For I equal to 1, I less than equal to n, I plus plus. Just say okay, maybe you just follow the procedure. Okay, you can easily find out the time complexity. I'll just tell you the way in which we should proceed. So same way, I is 1, j will start from 1 and it will go till, tell me, it will go till n, but how many times the loop would execute, or how many times the key to CS would be printed in this iteration? Tell me. J will start from 1 and it will go till n. How many times key to CS will be printed? That is what I want the answer for this. Clearly see this. J is not running here n times. J is here running for log n times. Because every time this j is incremented by 2. Are you getting my point? For I equal to 1, j would start from I. I is here 1. So 1 to n, it would go. Every time j is incrementing twice. So it is log n. Log n times. So key to CS would be printed log n times here when I is 1. When I is 2, j will start from 2. It will go till the same n. But this time, how many times the loop will run? How many times the loop will run? How many times the loop will run? Yeah, tell me. Okay, Satyajyoti, sorry. Satyajyoti says log n square. Okay, we'll check it out whether it is log n square or not. For log n square, it would be log n into log n. Are you saying log of n square or log n square? I want to say, are you talking about log of n square or you are saying log n of like whole square? I think you are saying log n whole square. Am I correct? Just say yes if I'm correct about you whatever you have posted. I think you have said log n square, log n whole square. Anyway, so I value is 1, j is starting from 1 to n, so the loop is running for log n times. So the key to CS is printed here log n times. When I value is 2, j value is starting from 2, not from 1. Okay, but the incrementation is same, j equal to j into 2. So can I say it is log of n minus 1? Because I have 1 less than the value of n. Yeah, I got it, second wala, yes. So can I say it is log of n minus 1? Because I don't now I don't have to start from 1 to n. Now I have to start from 2 to n, right? So I have this one less value and log is applied over it because anyway the j is incrementing 2 times. So log of n. But now I don't have exactly n values. I have n minus 1 values because I started from 2. Next time I value would be 3. So it would start from 3 to n certainly. 3 to n, right? Every time the incrementation is same. So I can I say this would be log of n minus 2 because I'm starting from 3. Two values I'm excluding, that is discarded. I'm starting from 3, but the way is same, j equal to j into 2, right? So similarly, if I reach here n, so it would be n. So can I say it would be log of 1, right? Okay, I can say, right, this is log of 1. So if you add all these terms, what is this? Log of n plus log of n minus 1 plus log of n minus 2, so on up to log of 1. If you do, how many terms are there? Okay, whatever may be the terms, what is this, guys? Log n plus log of n minus 1 plus log of n minus 2 plus so on up to log of 1. Okay, what is log of a plus log of b? It is nothing but log ab, right? Log ab is nothing but log a plus log b. So just apply the same formula here. So you would get here n into n minus 1 plus okay, not plus, obviously. Here you'll get n minus 2, so on up to 1. So what is this? N into n minus 1 into n minus 2 into 1. What is this? Yeah, what is this? N into n minus 1 into n minus 2, so on up to 1. It is nothing but n factorial. You'll get this as log of n factorial. So you can say this is the time complexity. Okay, n factorial. Got it? See, some people may say it is n log n. I won't say that is wrong because see, I won't say that is wrong because see this one thing. I'll just try to explain here. N to the power n is actually lower bound of your not this, obviously, n factorial. N factorial is less than n to the power n. When we are dealing with worst case time complexity big O, so we focus on tighter bound, but sometimes we can go for the outer bound, and here n to the power n would be outer bound of n factorial. Okay, right? So if this is the case, if you apply log on both sides, it would be log of n to the power n, and it would be log of n factorial, right? What is log of n to the power n? Nothing but n log n. Okay, n log n. So n log n is actually outer bound of log of n factorial. So you can write here instead of log n factorial, you can also write here this n log n. Okay, I don't say it is wrong, but I think the writing tighter bound would be better. Okay, this was the tighter bound. Okay, is it clear? Just stop at log of n factorial. You don't have to proceed further. Log of n factorial will do the job. Clear? Is it clear? Please post down in the comment. Is it clear to you? Understood? Yes. Great. Great going, guys. Others, if you have any doubt, please ask me. I would explain it once again, so that it would be. I don't want any like single. I don't want any single person like he or she would not understand. I don't want that. Everyone attending the session should understand whatever I am discussing here. Okay, we later on in upcoming session I'll also add some more problems. Okay, maybe we'll discuss some more concepts related to the time complexity and all. As I said, we'll not discuss here in this session. We'll not discuss the time complexity of recursive logics. We'll keep it for a different session. So, is this clear? Is this clear to you? Did you understand this? I just got one response. What about others? Is this clear? Just say yes, guys, or just put a thumbs up in the comment if it is clear to you. I hope it's clear. Fine. Okay. I will just move on. I'll move on to the next topic. Maybe not exactly next topic, some more example. Okay. See this. Okay. Just a moment. Fine. If I have this question for I equal to 1, I less than equal to n, I plus plus, and the nested loop is for j equal to 1 and j less than equal to n, and j, okay, what should we do here? J equal to j, okay, we will not do in this way. Let me give you another question, not this one. I equal to 1, I less than n, I plus plus, j equal to, I will start this from, let's say, n. J should be greater than equal to 1, sorry, j should be greater than equal to 1, and then j is equal to j divided by I. Let's say this is the question. Printf is the same thing, key to CS. Yeah. Tell me what would be the thing here? What would be the answer for this? I'll go with the same way. Okay. Start with this I equal to 1. I is 1. J would start from n. Okay. It go till 1. But how many times this? You can say. Can you say how many times loop will run when I value is 1? How many times this loop will run, guys? The increment, the updation of j is j by I. I is what? 1. So every time it is divided by 1. So what would you get? Actually, it should be, I should change this because when I is 1, every time you divide it by 1, n by 1, n by 1, n by 1, and it will not change. So what we can do here is, we can have a modification here. If you write this as j minus I, or it would be, maybe I think it would be complicated for you. Let's deal with some simpler example for you. Okay, we may go to this question in the upcoming sessions, like other sessions. So for this session, I'll not keep this question. It may be very complicated. I don't want to complicate things in this first session itself, because this session is just to make you comfortable with the time complexity, not to make you worried about this topic. Anyway, fine. So we have seen some problems. Okay, I think up to that point we are clear. Whatever, I'll discuss just one more problem. for this session, and we will end our session for this. Okay, we'll come at we'll come again in next weekend. We'll discuss some more topics. The next session would be on the next Sunday. Okay, timing would be notified. So for I equal to 1, I less than equal to n, and this should be I into 3. Let's say I'm just changing this time. I equal to I into 3, and then here for j equal to I, j less than equal to n, and here it is j plus plus, right? And the statement is printf key to cs, right? So what would be the time complexity for this? You go with the same way, go in the same manner. So just go with I value starts from 1, j will start from I, so it would start from 1, it will go till n. How many times this key to cs would be printed? Key to cs would be printed n times here. Then I equal to 2. When I is 2, j would start from, oh, I would not be 2, sorry, I would be next time 3, not 2, because I is incremented 3 times. You can see here I equal to I into 3. So next time I value would be 3, j would start from 3 and it will go till n. So how many times it is running? N minus 3. Okay, next, what would be I value? 9. Then from where this j loop will start? It will start from 9. Okay, and it will go here in this manner. So it is running from in times n minus, it should not be n minus 3, my bad guys, just pardon me, this should be n minus 2, because we are not starting from 1, now we are starting from 3, so 1 and 2 are not there, so just 2 less the values. And similarly here it would be n minus 8, so it would be the same question, right? Once we discuss kind of similar to that question, right? N minus 2, n minus 8. So you can see clearly this A is sorry, I is running for log of n base 3 times, and you can easily have this thing. You can get as we have discussed already, you can just apply the same way and get the time complexity for this one. Okay, right? Okay, so I hope you are clear with these things. Let's say I will give some more question on this. If your questions, like if you get an expression like this way, okay, you get this way, n plus n by 2 plus n by 3 plus n by 4 plus n by 5 and so on up to, let's say, n by n. If this is the thing you got, okay, if this is the thing you got, then what would be the time complexity? Like after applying those procedure, whatever we have done, after applying the procedure, we got this thing. Okay, if we add them up, we'll get a time complexity. So what would be what would be the time complexity for this one, for this procedure, for this expression? What would be the time complexity? Can anyone say what would be the time complexity for this one? Yeah, say it. Yeah, say it, guys. Okay, what would be the time complexity for this expression? If this is what we got and we just have to add this to give the time complexity, what would be the final expression or final time complexity for this expression? Say, say me. Yeah. Okay, I got big of 1 as the answer, log n as the answer. Fine. Okay, so it's very simple. Just take n as common. You'll get 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5, so on up to 1 by n. I think this is log n. Just check it out. Okay, this should be log n, and you also have n, so it would be n log n. Okay, it should be n log n. This expression, this thing, this part, this would be log n. This one is log n, so it would be n log n would be the answer. Okay, and also I'll try to give you some more kind of this expression. See this. Uh, okay, what we do, one, let's say 1 plus 2. Uh, okay, it is better if I give you a code snippet, right? That would be better. So let's say for I equal to 1, I less than equal to n, I okay, I multiply equal to 2, I multiply equal to, let's say, 3. Okay, for j equal to I, j less than equal to n, and j plus plus. Okay, pardon me, I'll just clear it out. Yeah, so j plus plus, and printf statement is the same, key to cs. What would be the time complexity for this one? Can anyone answer this? What would be the time complexity for this one? If I is starting from 1, I is less than equal to n, I into equal to 3, then for j equal to I, j less than equal to n, j plus plus, then we have only one statement, printing key to cs. So what do you think? What would be the time complexity for this one? Just work it out. I hope you can do it. Just work it out. Like follow the same procedure. Start, take I, then j would start from 1 to n. How many times key to cs would be printed? N times. Got it? Okay. Or what I do here is, let's say I'll change this. I think we have done this problem. J equal to I, j less than n. Yeah. The next time I'll get I equal to 2, and j value would start from 2, and it will go till n. So it will run n minus 1 times. Yeah, I guess this problem we have seen, we have already done. It would be n plus n minus 1 plus n minus 2 plus n minus 3 plus n minus 4, so on up to 1, and that was n square. Fine, I will modify this question a bit so that you'll get a different question. I'll just to do here, this j starts from 1 and j is less than equal to I. Now tell me. Okay, now tell me what would be the answer. This we have already done, so let's not repeat this question. I just got lost of the track of the questions we have discussed, so I was about to discuss the same question, but just do this one. I changed the question now. Do this one. J equal to 1, j less than equal to I, j plus plus. Do this one. So I will start from 1, j will start from 1, it will go till 1. How many times the loop will run or the key to CS will be printed? Only once, right? Then next time I value is 3. J value would start from 1 up to what it will go? Up to 3, because j is less than equal to I, j plus plus. So how many times key to CS will be printed? 3 times. Got it? Okay. Or to make it simple, maybe you will get confused. I will change this 3 to 2. First, let's discuss by taking 2, because it may be confusing to you if I take 3. First, I'll explain by taking 2. So if I is incremented by multiplying 2 every time. Next time I value would be 2, right? Next time I value would be 2. So j value would start from 1 and it will go till 2. How many times key to CS would be printed? 2 times. 1 and 2, for 1 and 2. Then I value would be 4. J will start from 1. It will go till 4. How many times loop would be, like the key to CS would be printed? Or how many times J loop is running? 4 times. From 1 to 4. Because the loop condition here is J less than equal to I, J plus plus. Condition is j less than equal to I, and it is incremented sequentially, one by one. So it started from 1 and it went till 4. So 4 times the loop is running, for j equal to 1, for j equal to 2, for j equal to 3, and for j equal to 4. Right. Similarly, next time I value would be 8, 4 into 2, because the updation is I equal to I into 2. So I value is 8, j value would start from 1 and it will go till 8. Okay. How many times the loop will run? 8 times, from 1 to 8. Likewise, what is the value? What is the last value of I? N. So how many times this will run? J will start from 1 and will go till n. How many times the loop will run? N times, from 1 to n. Right? 1 to n, right? So if you add these numbers, that will give us a total time complexity for this code. So 1 plus 2 plus 4 plus 8 plus so on up to n. This is what we got the expression. So what would be the result? What would be the time complexity for this? You answer. I have given you all, like we have already solved this. Okay, all the things I have written. You just have to add this up and tell me what is the time complexity here. Tell me what would be the time complexity for this one. Comment down your answer. 1 plus 2 plus 4 plus 8 plus so on up to n. Tell me, what is this? I'll just wait for a while so that you can post your answers here. Okay, log n. I got one answer as log n. Here, it is log n. Log n. We'll see. See this is nothing but this is a GP series, right? This is nothing but 2 to the power 0. This is 2 to the power 1. This is 2 to the power 2. This is 2 to the power 3. And this is, what is n? 2 to the power log n. That means how many terms are there? Log n plus 1 terms are there. You can say it is log n terms. Okay. In rough, because we are just dealing with the order of the time complexity and not the exact thing. You can say there are log n number of terms here. What is summation of GP series, like terms of GP series up to n terms? Summation of GP series of n terms. Okay. Okay, it is nothing but, what is summation of GP series of n terms? It is a into 1 minus r to the power n by 1 minus r. Right? What is a? The first term. What is r? The, this is common thing. This 2. This common ratio 2. N is a number of terms here. So if you put here this thing, a is 2 to the power 0 is 1. Okay. 1 minus r is 2. Number of term we can say log n. Right? Divide by 1 minus 2. If you solve this, what is the thing you'll get? Okay, you'll get 1 minus 2 to the power log n divided by minus 1. So this is nothing but 2 to the power log n minus 1. I've already said that you can ignore the constant terms here. So don't ignore 2 here, because it is 2 to the power log n. It is exponential right now, but it actually not exponential. Right now it is exponential. So this constant term 1 you can ignore. So you just left out with 2 to the power log n. What is 2 to the power log n? 2 to the power log n is nothing but n. So time complexity would be big O of n for this question. Okay, so this is big O of n, this code. So it may look like n square or some other stuff, like some might people will, some will see, okay, it is I is equal to I into 2. They will say it is running for log n times, and this is running for maybe same log n times or n times, some might think, and total they will say n log n or log n square, but it is actually n linear. That is why I said change your perspective, go as per this way of analyzing the code and not the conventional way. Okay, I hope this is clear to you. Is it clear? Because this is the last thing we are doing in this session. We will again meet in the next session, that is in the next weekend. Time would be notified. Okay, if this is clear, please put a thumbs up or just say yes if it was interesting, like if the session was good, or if you think that there need some improvement some in some areas, or whatever you need, just put down in the comment. I'll surely get through the comment. I'll just look in the comments, and it would be done for sure in the next session. Okay, just leave your thoughts in the comment box. Okay, like starting from like what should be the way or the topics you want to be discussed, or let's say on this time complexity, if any particular thing, if any specific thing you want me to discuss, or if any question you could not understand, you might want me to repeat in the next session, I'll do that. Okay, the video would be there. You can visit the channel and see the video for your reference. Okay, as many times you want, it will be there. But some point I would also like to hear from you. So just put those points in the comments so that I would see to it and improve myself, and it would be better for our sessions also. Okay, right? So, and also next onwards, I would roll out Google Form for the technical doubt, the doubts on the topic. But regarding this, you can put down in the comment. Okay, I hope it's clear. If no one has any doubt, then I'll just close this session off for today. Any doubt? Any doubt? Guys, just put in the comment box. No doubt. I'll have. I think I should put some more question in the next session. We would do some more solutions. We'll do some more solutions. Yeah. Right. Yeah. Thanks a lot. Thanks a lot for your comment. Yeah, that's really like motivating, and that means a lot to me. Okay, then, guys. I hope it's all clear. So we would again meet in the next session in the next weekend, that is Sunday. Okay, see, one thing is I'm not saying that we'll keep this fixed. Maybe it can be Saturday or Sunday, but next weekend surely it will be Sunday. I will keep you posted if there is any change in the thing. Also, you can comment down what next you want me to cover. I was thinking of continuing this time complexity thing, some other concepts obviously, but I was thinking about continuing this thing. But if you want me to cover some different topics, other topics, let me know in the comment box, and I would try to do that. Okay, so great then, guys. See you in the next session. Bye, and subscribe the channel. Okay, fine then. Good night, guys.